We found ourselves in the scenic mountain village of Engelberg, Switzerland.
Mountain of Angels.
We were about to learn more about an astonishing brain fact. The pink part at the back of our heads, our cerebellum, contains roughly 80% of all the neurons in our brains. Yet it can be severely damaged and we could still be enjoying this mountain view.
You can severely damage it, or people can even be born without a cerebellum, and it doesn't really affect their conscious experience. Of course, it'll affect your ability to walk smoothly and to speak and to your motor skills and so on. But your conscious experience apparently is unchanged. And there is a total parallel between how computers are typically wired and how the cerebellum is wired.
Jeremiah Hendren is an expert on integrated information theory, a theory of consciousness that doesn't look at information processing, but at the degree of integration of the nodes in a system, which it calculates as phi.
This looks like an integrated entity, this computer here.
Yeah.
But is it really, right, from its perspective? Okay, you have to go in and partition the system in every possible way to see whether intrinsically it hangs together.
Yeah.
And it doesn't just hang together for us as observers extrinsically. That is, you have to look at how things are built, not just on what they do.
IIT, if right, can calculate where consciousness is located, what its boundary is, and how it can expand. Not vaguely with metaphors, but formally with math.
If I want to try to account for my experience in third-person terms, if you like, right, which is the tools of science, objective terms, this is a reasonable way to do it. There is a way scientifically to reinstate the primacy of human experience in the scientific endeavor.
A very warm welcome at the Essentia Foundation's YouTube channel. I'm sitting here in Engelberg, where we are hosting a workshop called Beyond Physicalism, and it is about what's happening in the foundations of physics, quantum mechanics, and also in consciousness, and especially in integrated information theory. And at my table I have Jeremiah Hendren. Very warm welcome, Jeremiah.
Thank you very much.
I was very glad to meet you here, as when it's in quantum mechanics, the cliche is to say that the moment you think you understand it, you don't understand it. And I think I have the same going on now with integrated information theory.
Okay.
But
that shows promise. It shows that you feel that you understand something already.
Yeah, but I know I don't fully.
Okay.
And I'm happy I met you, because you're doing a PhD in applied linguistics research, and you're exploring ways on how to communicate integrated information theory better, right? You're working with Giulio Tononi on that.
Yep.
So you're in the position, I hope, to explain integration information to me and our audience. And I think it's important because it is a very promising theory of consciousness. A bit of a maybe naive cliche opening question to me is, can integrated information theory lead to a test of consciousness? We have the Turing test to test intelligence, but we don't have a test for consciousness. Can this theory give us a scientifically validated test for consciousness, so a meter to plug into our LLMs to see if they're conscious?
Yeah. So Giulio Tononi, who's the main impetus behind IIT, he had some very sharp insights starting in the 90s when he was working together with Gerald Edelman, the Nobel laureate. And this then developed later in the early 2000s into IIT, to the first formalization of the theory. And the basic approach or basic insight that Giulio had was thinking, okay, if we're going to try to account for consciousness, the way that we should do this is to look at the properties of consciousness or of experience. You might hear me say those two words interchangeably here.
Yeah.
So they mean the same thing more or less in IIT, right? It's the what it is like to be.
What sort of technically is phenomenal consciousness, but
you
consciousness
can call it
experience.
that if you want.
I think our audience
Exactly.
and I get what you're saying. Yeah.
And so Giulio had this insight of saying, well, we need to identify properties of consciousness through using introspection, right? Through using phenomenological techniques, looking at our own consciousness and trying to isolate certain properties that it might have. And this is where the name integrated information theory came from, where the first properties that Giulio isolated was looking at how our consciousness is on the one hand, informative, you could say. In really simple terms, you could say it's highly, a proxy way of thinking of it is it's highly differentiated, right? My experience right now is not only highly differentiated within the experience, but also differentiated from all the other experiences I could be having right now. Yeah. So on the one hand, it has this feature, this property, and on the other hand, it's completely integrated all the time. So even though I can, point out your nose and your eyes and your face, and also the background noise in the room of people talking in the other room, etc. Even though I can point out all these differentiated features of my experience, I'm experiencing them in a totally integrated, unitary way all the time. So these were the first properties that Giulio really isolated as properties of experience that we have to somehow account for in physical terms, right? And I'll bracket for the moment what physical means exactly, but let's just say, okay, in physical terms or in neural terms, yeah. Right? And so then getting to your question, bit of a long-winded way to it. But then if we look into the brain, what we should then, the insight from IIT is to say, we should look for properties that somehow reflect the properties of experience. But when we look in the brain, or we're turning to physics, we should try to do it in causal terms. We can also talk more about what that means. And this basic insight then led to a certain early measures of integrated information in a physical sense. You can think of this as a way of measuring the way that neurons are causally constraining one another or causally interacting with one another. And this then turned into a proxy measure, right? I emphasize it's a proxy, not an approximation of the actual mathematics, but it turned into a proxy measure of this value of integrated information, which has become very successful, right, in a clinical setting. And this, I can get into details of the technology and so on if you like.
Do you have maybe just a short example for people to understand how exactly it became successful?
Sure. So it was quite a stroke of genius, actually. With this was Giulio Tononi working with Marcello Massimini, who works in Milan now, but at the time he was a postdoc with Giulio. And they were trying to come up with some way to measure integrated information in the brain through some sort of a proxy technique. And so what they did is use a technique that's called transcranial magnetic stimulation combined with EEG, right? The standard net that people know, with all the little electrodes on it. And what they basically do is zap a part of the brain. They create a magnetic field and zap a part of the brain. And then you could say they record the echo of the zap. Right? So you stimulate a piece of the brain, and then you record what happens in the brain signature from that perturbation. Yeah. Right? And what they discovered is that when you zap the brain of a person who is in a normal state of wakefulness, like you and I right now, versus a state of deep sleep, let's say dreamless sleep, versus a state of dreaming sleep, versus a state of anesthesia, versus a state of undergoing a seizure, it looks totally different, right? That when you zap the signature or the echo, you can say, ends up looking completely different. Yeah. And so they said, okay, if we can somehow try to get from these echoes or these reverberations, these signatures, we can get some sort of a proxy measure of both differentiation of the signature and integration. Right? So again, trying to get at these properties of experience, but in sort of causal terms. And they did it in a really brilliant way, where they essentially used the same mathematical algorithm that is used in zip files, right? Where you're trying to say, okay, how much can I compress this file, right? Yeah. And if you have a picture of just a white screen, you can compress this a ton because it's basically
no differentiation.
There's no differentiation, precisely. Yeah. So it just has 5,000 white pixels, and so then you're able to say, okay, 5,000 times 1. All right, let's compress this thing down, right? Yeah. But if you have a really differentiated scene in a picture, right, in an image, it's very difficult to compress because you're not able to just say, oh, it's all the same thing repeated. And so they ended up coming up with an ideal threshold, right, based on compressibility that would somehow track pretty well with conscious versus unconscious states. And of course, they then have to validate this on on people who can report their experience. So that means, someone with a healthy, more or less healthy brain, where you can figure out what these signatures look like in a normal state of wakefulness, and then track it and say, okay, your average measure called PCI, perturbational complexity index, it looks like this in wakefulness, and in sleep it looks like this, and in anesthesia it looks like that, right? And you have to then track it in let's say healthy brains first, because you have to be able to report your experience. If I wake you up from a sleep state, and then I ask you, oh, were you dreaming right now, right? Or did you come out of nothingness, just from deep sleep without dreaming? You have to be able to report that, right? So this metric is first gauged on healthy brains, and then the idea is that the more rigorously it is validated and proves to be consistent in what in this threshold level with healthy brains, then the stronger the inferential power becomes when you're then trying to ask the question, is somebody in a vegetative state actually conscious or not, right? So it's a bit of a long-winded answer back. But
it is sort of, there's a lot here. I think first, for people to understand, so we're saying here that phenomenal consciousness, what it is like to be me, to sit here, see you, has sort of this ideal combination of being differentiated and integrated, right? And by formalizing that mathematically, as you said, and applying a smart way to measure it, not completely, because you would need to measure the whole brain, but you can do this proxy measure. You can measure that, and then that would be my question. People then report exactly what the theory predicts in these cases.
So the report is actually very simple. You basically just have to say, were you conscious or not? In that case, right? Because in this case, we're just trying to come up with a threshold, right? So if the threshold, if the PCI measure, right, the value is below this threshold that we figured out based on the reports of healthy subjects, if it's below that, then we can say, okay, this person is very likely not conscious of anything, right? And above that, they're probably experiencing something.
That differentiation I get, sort of, that's what we say. It's widescreen versus like an alpine scenery. It's now dark, but during the day we have a beautiful scenery here. That's highly differentiated. So that I get. I think a lot of people, when it comes to the word integration and integrated information theory, don't exactly understand what that means. Maybe nice to just unpack what in integrated information theory integration really means and how we can measure that in a system.
Okay. Well, integration, I mean, in experience, let's start there, right? Because it is indeed one of the core principles of the theory from a phenomenological perspective, to say every experience is integrated or unitary. So it's probably easiest to think about it in looking at different modalities that we are experiencing all at the same time. So let's say you are watching my lips move while I talk, and you're also listening to the words I'm saying. And those things feel completely integrated in your experience.
Right? It's not three streams. It's
precisely, right? So even though that's an auditory stream and a visual stream at the same time, they're two different modalities, but they're totally integrated, right? Now, someone might then say, what if we were having this talk over Zoom, right? And there was some bad, some latency in the connection or something like that. And you hear me going, but then the sound comes afterwards. Right? Now, some people would say, okay, now it's not integrated anymore. Now the experience is fragmented or something like that. But IIT says, no, it is still integrated, right? And the only reason that you even perceive that as being fragmented is because experience, one of the essential properties of experience, is that it is integrated, right? So what I mean by that is you wouldn't even notice that there's a disconnect between the auditory stream and the visual input you're getting if your experience weren't actually integrated. It is it's like the fact that you're experiencing the lack of synchrony between these modalities is itself integrated. Does that make sense?
I think
you wouldn't even notice if you weren't actually, you weren't having an integrated experience, you wouldn't even notice that there's disconnect between these two.
And I think a couple like one step back. What I like about IoT is that it starts with conscious experience. So it starts with this how I experience the world, and then you say that is integrated, it is differentiated, and there are a couple more axioms we can touch upon later. Maybe nice to juxtapose that to other theories of consciousness that don't do it, because I think that the 20th century has been sort of all about computation and computational functionalism. So if we can sort of simulate something on a computer, we nailed it. And we saw, I mean, in behaviorism, we saw just ourselves as a Skinner box with input output. So we have that sort of paradigm. A lot of people input, processing, output, me speaking to you. ChatGPT can do the same. I'm conscious, might be conscious. And that's where people are right now. And I think philosophically it's a problem. And then I think IoT goes against that, right?
Yeah, absolutely. I mean, there's a whole, I would say there was consciousness or experience was put into a black box somewhere around, I don't know, 1920-ish, people like William James in the early 1900s, they still spoke freely. Oh yeah. No, I mean, they were still very open-minded and so on, but then there were all these let's say waves of claims of pseudoscience or people. This is when let's say the philosophers of science became very rigorous about trying to define what is scientific and what isn't, right?
Positivism. And
precisely, right, with the rise of this sort of movement with the Vienna Circle and so on. And so certain topics, especially anything to do with subjectivity or consciousness, this was shoved into a black box, not to be touched for maybe 50 years, I would say. Starting in the 50s and 60s, some people started to open it a little bit. For example, in my field of linguistics, Noam Chomsky was very famous to, you could kind of call his movement of linguistics kind of first generation cognitive science a little bit, where they at least said, all right, let's open the box, right? Let's look inside a little bit. But the way of doing it was still, let's say, in linguistics, for example, Chomsky was then trying to only look at syntax, essentially, to account for language or to explain language. And he said, let's not touch semantics, anything to do with meaning, right? Because that's a little bit too woo-woo still, right? That we'll keep that in the box for a while. And so little by little, Christoph Koch, who we're here talking to at this conference, he was also saying that when he got started in the 80s, it was somehow okay to talk about awareness in a clinical setting, because physicians would somehow, use that word, but you weren't allowed to say the C word. You still couldn't say consciousness, right? Yeah. So anyway, over time through the 80s, the black box became a little bit more open. And then in the 90s, it was actually really due to Francis Crick and Gerald Edelman and a few other pioneers who were, let's say, old enough and established enough that they didn't care about their reputations anymore. Yeah,
interesting. But
so then they blew the box open and said, okay, let's actually talk about consciousness.
But their sort of approach to it, correct me if I'm wrong, was still a bit sort of materialist in a sense, sort of the whole quest for neural correlates. It's like, okay, I nailed DNA, Francis Crick, right? Okay, now let's nail consciousness by just finding the neurons.
So exactly. So now coming to the question a bit there, where we can be very grateful for these pioneers for at least sort of blowing this box open that we can even talk about the topic. But of course, what they did, or I can, to give Francis Crick as an example here, he basically imported certain let's say, paradigmatic assumptions from biochemistry, which is great. I mean, you have to start bootstrapping from somewhere, right? So basic assumptions about biochemistry and a certain, I guess, mindset of thinking about emergent properties, right, in a biochemical sense, right? You might, for example, in a really simple sense, you might say life is an emergent property from certain biochemical processes or something. Or even before life, you might talk about other, higher levels of biological organization or biological functions that somehow emerge from, this biochemical substrate. And so they imported this way of thinking into the first research done in consciousness science. And so this was very good to get things off the ground, to get the search for neural correlates off the ground and so on. But, to quote Giulio Tononi and Christoph Koch, who often say this, The problem is that if you start from the physical world and you try to squeeze out consciousness, right? I think that's the way Giulio often says it. It's never going to work. You're always going to be left with this classic thing called the hard problem of consciousness, right? If you're starting from the substrate as being what you think to be the base level of reality, right? You're always going to have this hard problem or this explanatory gap between, what you know about this physical substrate and the fact that consciousness is so qualitatively different from that. You're always going to be left with this sense that it's not really scratching your itch of explanation, right? There must be something else there.
Yeah.
So this absolutely is. I would even say it's pretty predominant in the field still, that people approach the question with this sort of emergentist thinking, and it's also applicable from a computational functionalist perspective as well. For the most part, the notion of emergence might be a bit different if you think it emerges from some, information theoretic construct or some mathematical, construct or something, or if it emerges from some neural firing pattern or something. The core kind of inference pattern is more or less the same. Yeah. And IIT is very different from that. It has a totally different approach to the question.
Yeah, indeed. And I find it funny that wasn't there this bat between Dave Chalmers, who sort of first phrased the hard problem of consciousness, right? How do we get from sort of the neuronal activity in our brains to minds, the wine of consciousness, right?
Yeah.
From the
water. That was McGinn, Colin McGinn.
Yeah, and then there was this bat, I think, also between Christoph, who was still sort of finding those neurocorrelates, and he lost it, right? So where we are right now is that the hard problem is pretty much established. I do think, in society and culture at large, we find it very hard to not think that complex computational systems can give rise to consciousness, right? So why exactly in IIT is our Turing machines, let's stick with computation we have nowadays, our big LLMs are in the end all Turing machines, right? And why can't they be conscious according to IIT?
Ooh. Well, you have to look under the hood in IIT. What I mean by that is you have to look at how things are built, not just on what they do. So something that we often say in IIT is that consciousness is a question of being, not of doing, right? So it takes a bit to maybe contemplate what that means, but in more practical terms, most paradigms are functionalist paradigms, meaning it's about doing something, right? That you think consciousness is about somehow performing a certain function or computation, something like that. And so LLMs can indeed do much of what we can do, and especially if it's combined with some advanced robotics and so on, they'll end up being able to imitate our behavior, assumably, I would assume perfectly eventually. But the problem from IIT's perspective is that they're not built the right way, right? Quite simply, where IIT says consciousness isn't produced somehow because of some sort of a function that you're doing, right? You can build a system that is, let's say, functionally equivalent to a human, but the wiring, to make it very simple, the architecture, the neural architecture, is going to be completely different from a human brain's architecture. Then it might end up doing exactly the same thing, right? It might be just as intelligent, right, in the way that we measure intelligence based on behavior and functions and so on. But because of the way this thing is built, because of how it's wired, it isn't a conscious entity, right?
I liked in Giulio Tononi's book Phi, where he compares sort of the brain to sort of a DSLR camera, because we talking about images and just seeing stuff. Our cameras here I have Retina, and they have sort of a CMOS sensor that reads out the photodiodes and gives the picture in the end, right? So we end up both with the picture, and actually the cameras nowadays might even have a higher resolution picture than I do. Yep. But if as you say, we look under the hood, I see quite neatly organized photodiodes on that sensor that, correct me if I'm wrong, aren't truly interconnected. The one sits next to the other and doesn't connect to the other one. It's just in the end of the processing, it gives us that image.
Yeah.
So I guess then integrated information says that photo camera is not integration low.
Yeah.
But processing power probably high. I can give 8K video stream image. So that's good computation. Output high, but integration low.
Yep, exactly.
So and then the theory would say, okay, therefore the camera is not conscious because its integration is low.
Or even non-existent, actually, in that case. So yeah, you can think of the way most computers today are built. And by the way, before I say too much, I should give credit to especially my colleagues, Graham Findlay and Billy Marshall, who recently came out with a great paper that's called Dissociating Intelligence from Consciousness. I should know the paper by heart. But in any case,
that's interesting.
We call it computer consciousness for short in the lab.
We can put links below in the description.
Happily.
Actually, nice to just park that one for a bit. Just intelligence versus consciousness. It's just
but it's this question actually of LLMs basically.
Yeah, indeed.
Or it's even to some degree the camera related to the camera
please
question.
Please unpack.
So in a really simple sense, computers is how they're typically structured. People refer to it as feed forward processing, where there's not a lot of crosstalk between modules, right? And so information is kind of sent up this hierarchy and different, feed forward streams in through different modules, and it ends up being processed at higher levels, and then creates some sort of an output, right? And so you could, in theory, build a neuromorphic computer. And IIT would say something different about that case, right? You can just table that though. But if you just compare the way, computers or also your digital camera there, the way it's wired, it's totally different from how the brain is wired, right? And without getting into too many details, the LLM or the computer powering the LLM, it simply as a whole does not have what we would call a maximal of integrated information. It simply isn't. It doesn't hang together, you could say, as a single entity, right? It doesn't actually hang together. It hangs together for us when we look at it, right? And its functions seem to hang together for us as extrinsic observers of it. But in itself, to use an IT term, from its intrinsic perspective, if you will, it's not really a thing, right? It doesn't hang together as a thing. But if you look at a human brain, it indeed, or at least certain parts of the brain, we should be very precise, the substrate of consciousness, which is a sub-portion of my brain. In IIT, it's predicted to be a region mostly of posterior cortex. We call it the posterior hot zone. And this part of the brain is wired completely differently, right? In a fully integrated system. And interestingly, to even draw a parallel to the brain, there is a certain part of the brain that's actually wired more like this computer, and that's the cerebellum, right? This little mini brain that we have underneath.
Okay, there the neurons have less crosstalk.
Absolutely.
They're more
everything is much more modular, much more feed forward. It kind of imitates the way typical computer architecture is. It sort of imitates a bit the way a cerebellum works. And interestingly, one of the very early insights that Giulio had as a neuroscientist was, it seems awfully curious that the cerebellum is something like 3/4 or 4/5 of the neurons in the brain. It's something like 60 billion neurons, I think. And apparently you can severely damage it, or people can even be born without a cerebellum, and it doesn't really affect their conscious experience. Of course, it'll affect your ability to walk smoothly and to speak and to your motor skills and so on. But your conscious experience apparently is unchanged. And so that should be a very interesting insight, right? So there is a bit of a parallel. This is one of the original, intuition pumps that Giulio had for thinking about consciousness. And there is a total parallel between how computers are typically wired and how the cerebellum is wired in very rough terms.
That I find interesting, because that to me, that really helped me to sort of, that's really in favor, I'd say, of IIT as sort of a scientific theory to sort of measure, so to speak, consciousness, because up to now we had to do with like the reports, and then you would end up just with like a Turing test for consciousness, because but that we are already there, right? If I talk to our LLMs, how do you feel? I'll get like a conscious simulation. It will be hard. So that test is already passed. But now we have a way to say, because in humans you can damage the architecture that is the same as the LLM you're saying. So in the cerebellum we have a sort of actual. If we can and still the person reports consciousness or shows consciousness, and where if we damage the cerebrum, so in the hot zone we damage stuff, then we see consciousness sort
absolutely
of really being damaged
in the right areas. Yeah, absolutely.
Okay. So in IIT you can measure the amount of integration, right? And that's called phi. Is that the way to put it?
Yeah.
Okay, how to measure it?
How to measure. Yeah. Okay, well, so this is where we can really distinguish IIT as a theory, right, with a capital T, a theory of consciousness, because it, of course, takes certain insights into how the brain is wired, how the brain works, and so on. It uses those insights to inform the theoretical development, but the actual theory itself is highly mathematical and based on working with what we call toy systems, right, toy models. And the reason, so it might mean, for example, a model of 6 neurons. We can call them neurons, but we tend to use a more generic term like unit, because it might also be modeling, entire mini columns in the brain, or even whole cortical areas of the brain, right? So we just say we try to build a model of 6 or 10 or whatever units, right? You can think of them as neurons for now.
Yeah.
And in order to become a proper theory, at least from IIT's perspective, right, with a capital T, you want to be as precise as possible, right, with what you're really articulating. You want to be more than just a good metaphor or a good kind of hunch, right? But you really want to be as mathematically rigorous as you can. So with this aspiration, we intentionally work with idealized, toy systems, right, of neurons like this. So the way that this calculation of phi, right, the way this is done is very precisely formalized based on these toy systems. The major challenge, and as a shout out to any possible postdocs out there, but the major challenge is then saying, okay, how do you relate this theoretical model, which is very elegant, really, and very insightful, right? Offers a lot of insights also into thinking about what to look for in the brain and so on when you look for neural correlates, etc. But scaling up, if you like, from 6 neurons to 80 billion, it's not so easy, right?
Yeah, I can get that.
Yeah, and so just as a simple example, I think the software that we use right now, that's called PyPhi, right? It's a Python software to use to calculate phi.
Yeah.
I think it maxes out somewhere around maybe 30 units. And then beyond that, it's just astronomical, the amount of compute you need to actually compute phi precisely, right? Yeah. Somewhere between 20 to 30, I think it maxes out.
But the interesting thing to me is that you can have a system that sort of computationally has the same power, right? Like say a very simple toy system, as you call it, like 6 nodes. And then computationally you have one that is only has feed forward, like modular computation as we know it. And the other one is highly integrated. Very high integrated. If we would put a scheme, it would be like, just like lots of cross connections. And then IIT predicts that even if that system which has a high phi perhaps even has less computational output, it still is more conscious than that system that is not integrated, right? That's sort of an implication of the theory.
Yeah. So So
I asked this, sorry, but I asked it to distinguish between intelligence and consciousness, because it points to the fact that sort of our LLMs because we are so wired to associate those two together.
They're
we always in nature we always see. That's what Christoph told me also. In nature, we just see this line. If intelligence goes up, consciousness goes up, and we're used to this curve. And that's what's so weird the times we're living in. That maybe we now have systems that are super intelligent but not conscious.
Yeah. So they can be completely dissociated within IIT's framework, right? Intelligence, you might have something that's hyper intelligent, even way better than you and I are with any human or quasi-human function, but completely no consciousness, and vice versa. versa. You might have a system that's highly conscious but not intelligent, right? So this is what IIT would predict, right? They're totally dissociable. But it is also useful to point out that in nature, what we probably see, and this is, let's say, part of the implications of IIT more than the actual formalism of the theory itself. But in nature, because of pressure of evolution, actually our colleague Larissa Albantakis has done some work on this to show that there is arguably evolutionary pressure, which is of course functional pressure, right, to survive. There is evolutionary pressure that ends up favoring integrated systems rather than or modular systems, right? So there is, so I'm trying to say, even though these intelligence and consciousness can be dissociated in theory, and they should be, right, according to IIT, in evolutionary terms, probably they usually go together, right, pretty tightly.
That's interesting, because it points to me, it points to that consciousness has a function in evolution. Well, I believe, why else would sort of evolution favor for systems that have that integration, that evolution favors for what it is like to be something?
Yeah. I don't know.
Or am I sort of off here?
I think it'll be a slippery slope. Now, the reason I kind of, shake my head a bit is to say, this sort of framing of the problem, it's very, very commonly adopted by, let's say, functionalist frameworks to somehow justify why consciousness is sort of along for the ride, right?
Yeah.
But it's a slippery slope, because usually the way, the paradigms that these, the paradigms of these theories are treating consciousness as just another function, right? And I guess from IIT's perspective, it isn't just another function. I mean, from yours and my intrinsic perspective, it's literally all there is to existence. I mean, our consciousness. I mean, without consciousness, what are we even talking about when we talk about existence, right? I mean, this is the approach that IIT would take there. Yeah. So, I don't know. I think in IIT's terms, we probably wouldn't think about the utility of consciousness for survival and so on. Or I think I'll get into hot waters if I try to get too far in that direction, because people immediately think of it from a functionalist view. Let's
tackle sort of another interesting thing about IIT, and that to me is its substrate. On the one hand, it's highly focused on the substrate. That was when I first encountered IIT. That was sort of what put me off. But I was new into consciousness, and I was like, this is again sort of a very brain-based theory. No brain, never mind. So, and I didn't only to discover later that the theory is actually quite substrate independent. So sort of it says it needs this integration, but it could be, as you already said, it could be neuromorphic chips, for instance. So could you sort of talk a bit about that? So to what degree can anything that is just integrated be conscious?
Okay, so I think our lead up until now, we've been touching on many different little bits here and there about the theory, but maybe it's useful to offer a kind of IIT in a nutshell to formalize it a little bit. I think it would be useful at this point, where IIT takes a very different approach from standard approaches to the question of consciousness. And before we even get into the approach of IIT, it's worth it to even articulate what are the key questions that it's trying to ask. Because I think when we have the questions clear, you also see these, let's say, differences of the theory with other approaches even very starkly. So you can think of there being two key questions. The first is, why is consciousness present versus absent, right? And this you can think about both in ourselves, right, in a relative sense, meaning, let's say within ourselves, some parts of my brain are conscious and others aren't. Why is it that part of my cortex is conscious, but my liver isn't, right? Even though I am conscious somehow, or my cerebellum isn't, or whatever. So this present-absence question can be, presence versus absence question can be applied on that level, or even within the part of my brain that I know to correlate with consciousness, namely probably some part of the posterior cortex. why is that sometimes conscious and other times not, right? Which is equally fascinating, because if you just look at brain activity, it's going, from the day we're born until we die, there's activity, and it's wild. It's all over the place. I mean, even in anesthesia, there's activity, right? So the same substrate, because of certain, neurophysiological modulations, ends up being conscious sometimes and other times not, right? So this presence versus absence question it's deep, right? But it's actually, that's the easy problem in this case, right? The much harder question is the second one. And this is, I'll say, when I was learning IIT, this is where I said, oh, this theory really has some interesting explanatory power, right? Because the second question is about, why do specific experiences feel the way they do, right? So what this is in the philosophy of mind literature is referred to as qualia often, but just to stay out of jargony terms, I would say this means that we have to not only account for being conscious or not conscious, but we also have to account for why does, if you like, this red cup feel like a red cup, right? I'm not talking about what it is, in an extrinsic sense, but it feels like a cup, it feels like an object in the shape of a cup. It has this hue of being red, and that is different from the feeling of what it is like to smell lavender or whatever else, right? Yeah. And there must be some systematic reason why this feels like that, and lavender, the smell of lavender, feels the way it does, and countless number of other experiences feel the way they do, right? So this second question is, the first question is already tough enough, right? The second question is really tricky, right? Yeah. And so you can think of this is what I would call a proper theory of consciousness, has to actually answer both of these questions, or at least provide a plausible path to answing both of these questions in a thorough way.
Jeremiah, I know that this is a bit of a sort of I'm just saying what a lot of people think, namely that under fMRI or EEG scanners, we can already sort of think about an apple, we can see something light up. Oh, that's the apple. Sure. Neuralink can read it out. So aren't we there already? So you're sort of...
Depends on what one means by answering a why question, right? So there are certainly some people, if you say, okay, why does the apple feel the way it does? And then someone says, oh, it's because these neurons are firing in visual cortex or something or whatever, right? Okay. Well, does that scratch your itch of explanation or not? For some people, they might say it does. Other people might say, no, this feels, there's some correlation between these things, but they're apples and oranges when you try to, draw some meaningful, relate these in some way, right? Yeah. You're still left with either the hard problem or the explanatory gap or whatever framing you like, right?
It's not causation. So it's this correlation, but not causation.
It's even beyond that. I honestly think of it in very simple terms of it doesn't scratch your itch of explanation, right? There's this gap between, why should it be that these neurons firing there in the brain somehow correlate with apple, and those neurons firing there correlate with banana or whatever else? Yeah. That doesn't, okay, you can try to force it. It's been there are old theorists that are called, let's say, classical identity theorists. And they would say, well, there simply is an identity between this mental state, they would refer to it like that, and this brain state or brain process. And they say, that's it. There is this identity. And then other people came in and said, okay, that's just a brute identity. You're just sort of mashing these things together, saying that they're the same thing from different views. But they're clearly not. They don't somehow, there's no explanatory power in that, right? And so to answer your question, some people will say that's the answer why red feels red or the apple feels like the apple. But many others would say, okay, it's just not satisfactory as a proper explanation, right? It's simply a correlation. Yeah. Right? And it's not that you have to figure out the causation of those neurons producing the red necessarily, right? Most people think that's the next step. But there are other ways of also approaching this to make it more explanatory.
I'm not saying that I believe in that. Because what fascinates me are these sort of the anomalies. If you say it's all just neuronal activity and it is explaining, I'm not saying I believe, but if you say it does explain it, because every time someone reports seeing an apple and it even smells like this or that. I can see exactly this light up. Okay, that explains it. Okay, even if you do believe it, you still have anomalies, right? But because there are cases where we see neural activity going down, but reports of consciousness going up, right? That at least in psychedelic research, and that's what fascinates me, and that's what I hope. But what can IIT say there? Brain activity, like neurons firing low. We know the system is highly integrated, so say in a cerebellum, but the neural activity is low. IT can then still account for consciousness, or how do I say it? Can you still see if someone is then conscious?
Well, so I would like to come to that question, but can I give a little bit more framing before?
Yeah, of course, please, because I know I'm not phrasing it maybe correctly.
No, this is a really interesting piece of research that's happening now, and we sometimes refer to it as like a silent cortex hypothesis, right? Where IT does, I'll give a teaser, right? IT does make a prediction that if you have a cortex that is relatively silent, I mean, getting complete silence is basically impossible for for normal humans, right? But if we can get a cortex that is very, very quiet, where basically let's say all of the neurons are in a state of being inactive but not inactivated, right? Inactivated means they're dead, right? They're just they couldn't turn, they're not going to fire even if you zap them with something, right? But if we can get a cortex that is completely inactive, not inactivated, IIT would be, I would say, the only theory to actually predict that this would also correspond to a state of consciousness, a state of awareness. And it would even go on beyond that to predict that the way it feels would probably be expansive like space, right? A sort of like open canvas, like expansive space, right? Okay, but to get to that point, all right, to get to that prediction, it takes understanding a bit of IIT. Okay, so there's a teaser, all right? So interesting prediction. There's also some empirical work being done on this with long-term meditators and things. So, but I would like to lay out a couple of IIT essentials, if it's okay, because I think this is a very fun talk, but I think I want to get a few things on the ground first. So, as I was saying, to be a proper theory of consciousness, you have to answer both of these questions, or at least have a key avenue to answering, right? So, why is consciousness present or absent? And why do specific experiences feel the way they do, right? You're not going to ever account for every single experience, literally, right? Or I don't think we will. But you have to at least have a plausible way that you would even start to account for those. And so IIT says the way to answer these questions is to be first of all, we have to have our starting point clear, right? And you could say IIT is one of the few theories that really takes Descartes very seriously, right? So many people know Descartes for his famous dictum, I think, therefore I am. IIT has its own version of this, where we simply say experience exists, right? Or you can say my experience exists, but who am I, right? All I know is I'm not going to posit a self or anything like that, but I'm simply going to say my starting point for my science of consciousness, or if you like, actually of any science in IIT's perspective, but let's start with consciousness. My starting point must be the fact that I'm having an experience right now, right? Or let's just say experience exists, to not try to import some ego or sense of self or something. Okay, so that's our starting point. Not anything that we know about the standard model of physics, or all the richness of biochemistry we know and so on. We're not going to start from there, because if we try to follow Descartes' kind of skeptical impulse, all of those things that we say about the outer world, right, through science, they seem to work pretty well, right? But at the end of the day, they're inferences, right? They're logical inferences that we make from within our experience. And so you can't somehow, for IIT, it's putting the cart before the horse. If you start from the outer world to try to squeeze consciousness out of it, right? And it's putting the cart before the horse, because the thing we know directly, right, what's called in philosophical literature by direct acquaintance, if you like, or I like using the word, what we know immediately is our consciousness or experience itself. And we say sometimes the word immediately because it's not mediated by anything, right? Even if you came and told me, right, I'm sure you are not conscious, right? Telling me, Jeremiah, I'm sure you're not conscious. I have the latest brain consciousness meter, and we are sure it's reading 0, and I'm sure you're a zombie. No matter what you're going to tell me with the most cutting edge technology, you're never going to convince me that I'm not conscious if I'm having an experience, right? Because I know it directly. I know it immediately, directly. It's impossible to refute that from any external evidence. Yeah. Okay, so IT really stakes its flag firmly with this, let's say, first we even call it a 0th axiom, right? Yeah. I mean, it has to be the starting point of the science of consciousness.
And just one brief interruption.
Please.
Other theories of consciousness would then say we start from that second category Descartes invented, right? The dualistic category.
Precisely.
Of the res extensa, the stuff out there.
Yeah.
And they start off with their no, we don't know if consciousness exists. We know that brains exists.
Yeah.
Okay, that's just my...
And of course you end up leading, I mean, if you really follow that... Well, so I should first say, I think most people who are, let's say, neuroscientists or people studying consciousness from the, let's say, typical neuroscientific paradigms, I don't think they're thinking much about Descartes or they're usually not getting into those frameworks. It's more like, let's import the way we study other phenomena within biochemistry and physics and now apply it to the problem of consciousness. It's more like that. It's often more unconscious. People aren't really thinking about, am I aligning with Cartesian skepticism or whatnot?
No,
right?
Indeed. Yeah.
Okay. I lost my train of thought.
Sorry, I interrupted you. You said firmly that flag in sort of consciousness is primary. You take that as your starting point.
And and in fact, if you follow the other line of reasoning where you say, well, I'm going to be skeptical about, or I'm not even going to talk about consciousness yet. I'm rather going to start from the brain, so to speak, right? If you really follow this line of reasoning, you can even end up with a theory that's called illusionism, where you say, oh, actually, it turns out consciousness doesn't really exist. There's just an illusion that I think I'm conscious, but I'm not really. Yeah. And I feel as I've never understood how this could make any sense. Right?
That one to me is totally alienates me.
I think it's...
Or I just say, but then the illusion is what... Then the illusion, I experience the illusion. So I'm back.
Precisely.
For me, I'm back at the starting point.
Yes,
I'm back there.
Cartesian.
Okay, now I'm experiencing an illusion. So you're not explaining anything.
Yeah, there's one well-known philosopher, Strawson, who said something to the effect of, this is the silliest statement ever made, or something like that. I'm paraphrasing it. I'm just saying, how can you end up, gutting the one thing that you know immediately, which is your own experience,
right?
I
think... it's a really weird place we ended up in Western thinking to end up with that.
It's very funny, absolutely. Yeah, it's very funny. Okay, so IT starts with this approach and says, not only do I know that my experience exists, but I can also start to characterize the properties of my experience, right? And we gave a teaser of this, half hour ago at the beginning, talking about information and integration, these kind of core insights that Giulio had of thinking about what properties does my experience have. In IT over the years, it's gone through a couple of iterations. Now it's in we call it 4.0 now, the sort of fourth iteration of the formal version of the theory. And it tries to articulate the properties of experience in a pretty systematic way, right? So it starts by looking at what we can say are essential properties to every conceivable experience, kind of repeating the Cartesian method, right? Of saying, what else can I say about my experience? Not just that it exists, but what other properties are always there, no matter what the experience is, right? I won't get into the details of what those are, but that's the general approach. And then later it also uses this introspective technique to try to identify what we refer to as accidental properties of experience. That's just a fancy philosophical jargony word to say, the specific properties that are there sometimes and not there others, right? So some experiences are red or have red in them, others don't, right? Yeah. So those are accidental properties. So IT tries to use phenomenological techniques or introspective techniques in order to characterize the thing we're trying to explain, right? The explanandum, to use a fancy philosophy word, right, for it. And I think this is something to dwell on for a sec, that it's a real quality of IT, where if you think about other scientific pursuits, we also do this by default. You know, if I'm trying, I don't know molecular theory, and I'm trying to come up with some scientific account of water, right? My first step should be not just say, I'm trying to account for water in some nondescript way, but I should get in and say, okay, what are the properties of this thing that I can isolate? So I might say, I notice that, it's a very, it's liquid at room temperature. And if I go outside and, the Swiss Alps, it might suddenly turn to freezing at a certain, predictable temperature, and it boils at this temperature. And, when it freezes, if I get out a microscope, I see it makes these sort of lattice-like structures and whatever. And what I'm doing there, before I have my molecular account for it, or I guess the lattice structures probably require some, but anyway, but before I get to my account of it, I'm characterizing its properties, right? And I can't end up having a scientific account of this thing that only accounts for one or two of those properties, right? I can't just say it's, I account for it because its nature is wetness. This is sort of a bit of a parody on old Greek accounts. Sometimes you say, okay, we can do better than that, right? Yeah. So I have to first try to say all of the properties I can isolate in what I am trying to explain. Yeah. And then I say, okay, how am I now going to explain these things, right? And explanation is always trying to characterize something in one, let's say, domain of knowledge, and then drawing a parallel or explaining it in terms of another domain of knowledge, right? So with water, we kind of, the first domain is this sort of phenomenal domain of, observing water-like qualities. And then we try to account for it in this other domain, which is molecular theory.
First principles.
Exactly. Okay, so IT is trying to do something similar, right? And it really dwells on this first step of saying, we have to know what it is we're talking about, right? Now, of course, in this case, in the water case, I'm using an objective characterization of both the thing I'm trying to explain and an objective theory to do the explaining.
Yeah, because we all can agree. They're both objective. We can all agree on the fluidity and all that stuff.
Precisely. Right. Now, in consciousness, what's funny and why it hasn't been touched with a 10-foot pole for a century, basically, is that your object of investigation, if you like, is subjectivity itself. Yeah. And so you say, right? How am I going to deal with this, right? Galileo famously relegated this to the unscientific, world for 400 years. So that's tricky, right? But IT says, no, we have to actually face the fact that you need new creative scientific approaches, and we should try to come up with some systematic ways of doing these introspective steps, right? And I think there's still, room to do more also in the IT world to become really systematic with how we do the introspective steps. But there's no way of getting around that this, in order to figure out what this explanandum is, we have to use these introspective methods of looking at our consciousness from the inside out to figure out, okay, these are the properties I want to actually
because otherwise we don't even know what we are explaining.
Precisely.
Right? So that's, I think, a problem in a lot of consciousness. We don't know you don't know what you're explaining. Okay, but say we know exactly what we're explaining. Say the axioms of IIT are right. So differentiation, integration, information, all the five. We will put all links below.
I've been trying to stay away from jargon. No, I know. I'm talking around them. I'm trying to do my best to not get into IIT jargon and so on, and leave it in regular terms.
Say they're all right, then the claim IIT seems to make is that for a very specific conscious experience, the experience I'm now have at this moment, you can find the structure of, and Koch says, like the unfolded cause-effect structure, stuff like that. We cannot avoid jargon, right, when we talk IIT.
Okay,
so,
all right.
But let's go there.
So how do we do that? How do we get from here to there?
Because how I see it is, let's say the landscape, let's say the territory of consciousness is me sitting here with you. And it seems to me that the claim IT is we can give you, Hans, the exact map, the exact map of that. Sure. And not in neurons firing, but in this unfolded cause-effect structure. And then I see in your papers, I see these beautiful unfolded crystals and stuff. But I must say, on a certain level, there it becomes very abstract to me, and I don't know what to make of it. Yeah,
okay. So let me try to walk through it, and I'm really gonna do my best to avoid IIT jargon. We're certainly not going to talk about math because I can't get too far into it. A little bit, but not too much. So let me try to paint it in broad strokes. And there might be a few visuals that you could throw up afterwards to illustrate some of the ideas.
Yeah, it helps.
Okay, so once we characterize, our experience by trying to identify its properties, right? We first do it with essential properties, then later with the accidental ones, but we don't have to get into those details. We end up with what we can call a phenomenal structure, right? And in simple terms, you can say any of our experiences we can really end up characterizing in actually structural terms. Like this view right now, right? I'll describe my view right now, right? It has a certain structure, meaning it has components of my experience, right? Let me just focus on visual components right now. I have your face here, the microphone there, the sort of the greater room around me, a couple of cameras, and so on. So I can isolate these different bits of my experience, but I can then also see how these components of my experience are related to one another, right? So I don't just see, your eyes and your nose and your mouth as independent, free-floating components, but they're actually integrated as a face also, right? And that has something to do with the way these components relate to one another, right? And you can do a similar analysis with, all the different modalities, with smell, with audition, etc. I think the structure notion is easiest to get across with vision, right, as a core modality. But IT approaches this characterization of experience in structural terms and says, okay, let's try to isolate, what we call a phenomenal structure, right? Think about experience as a phenomenal structure. And it's this phenomenal structure that we're trying to make sense of in, let's say, physical terms now. Yeah. Okay? Now, in this step, it's important to be super clear about the methodological assumptions that IIT makes, and especially about what it doesn't make. Okay? So, IIT tries to stay true to this Cartesian skeptical commitment all the way through the theory. So what do I mean by that? I'm sure my experience exists. Anything I say about the outer world, I know is sort of an inference from within my experience, right? So I want to be as parsimonious as possible as I can when I start going from the world I know directly to the physical world. All right, so let's be as parsimonious as we can be. First, I'm going to posit something I call realism, but not with a capital R, right? Not the way many people misunderstand this. I just mean, I'm going to say that there is a world beyond my experience. Something exists besides my experience. I like phrasing it in that very open way, because I'm not saying I'm sure it's the standard model of physics, I'm sure, whatever subatomic particles really exist. I'm not going to say any of that. I'm just going to say, because of the regularities I observe in the world, right? Because of these regularities, like when I put this glass here, it somehow stays stably there on the table. And if I repeat that action 100 times, the same thing happens 100 times, right? In contrast to that, in a dream, it might, suddenly fall off the table or suddenly turn into a tiger or suddenly whatever. So there aren't regularities in our experience. But in normal wakefulness, there seem to be regularities in our experience. So because of this, I'm going to say, all right, something beyond my experience exists, right? Now, if I want to figure out what else exists beyond my experience, what are the tools I can use? Well, very simply, if I try not to posit any real nature of matter or something like this, the best tool I can use is what we call perturbation and observation, right? Or manipulation and observation. So again, I'm going to say, if I push this glass over here, I'm able to, exert a cause on the glass, and it's able to bear an effect. Right? And let's sort of suspend, I mean, even when I say cause and effect, you can even think in a sort of Humean sense where it might just be correlations in the end, right? But we use the term cause, effect, power for this.
We experience it as cause and effect.
Sure, but exactly. And we can still stay a bit agnostic about whether it's sort of mere, billiard balls hitting each other in a correlation or real causation, right? We can stay agnostic a bit, but we use the term cause, effect, power. It's a bit more sophisticated than just causal power. It's because of how the theory is formalized. But you can think of it roughly as just causal power, right? So I say, I'm going to use causal power as my method to figure out what else exists out there in the world, right? And we call this also operational physicalism. And I think it's a useful term because we do use the word physicalism, but it doesn't mean, your standard materialism, or it doesn't mean, physicalism in the sense of whatever modern physics tells us about the world is what we take to be the starting point, right? We simply mean, physical means essentially causal. It's basically synonymous here. So we say operational physicalism in the sense that simply perturbing things in the world and looking at effects of those perturbations, that is my best operational way to figure out what actually exists out there.
Yeah.
Okay, but I'm still agnostic about the true nature of the things out there.
It also sounds like a bit methodological also. Like
super methodological.
Yeah, it's like epistemic. You're not saying like ontically I'm
it's
claiming
really,
that
it's trying to be as parsimonious as possible. And I love that about the theory. Other people hate it. They think it's too, let's get into some neuroscience. Okay, that'll come later in the theory. All right, so we have this operational physicalism. And then we also have this assumption that we call atomism, or also you can call it methodological or operational reductionism, right? Okay, that word can be very poorly misunderstood, right? Reductionism. So what we mean by this is not an ontological reductionism. We're not trying to say, this glass is nothing but the atoms and the, subatomic particles that constitute it. That's not what we're saying with reductionism or with atomism. We're rather saying that in order to figure out what exists out there in the world, I have to try to go down to the lowest level of units, of things that I can manipulate and observe, even if I don't know what those things are, right? Practicing science means we should be committed to going as low as possible, right? In let's say with our atomic eyes and atomic hands, we should try to go to the lowest level possible of manipulations and observations to make sure we're not leaving anything out of our explanation, right? So that's what we mean by this sort of atomism. All right, so with these methodological assumptions, we then, let's say, we start getting science off the ground, right?
Yeah.
Okay. So when we try to then say, we've accounted for our experience as a phenomenal structure. Now, when we go to the physical world, again, with our realist assumption, lowercase r, right? We say, it seems that consciousness somehow has something to do with brains, right?
Yeah.
Okay, so there's something about...
Fair enough.
Exactly, right? Something to do with brains. Well, I mean, people used to think it was the heart and all sorts of other things. But anyway, but we know it has something to do with brains or a certain part of it. And so I'm going to now try to approach a brain or some... we talk about things in terms of just units to not be too much of a neural chauvinist here with the approach. But we say, okay, the brains have something to do with consciousness. Now, what I should try to find in, this cluster of neurons over here, or of mini columns, or, the neural substrate, I should try to find properties that are causal properties that somehow can map onto the phenomenal properties that I articulated here, right, through my introspection. Yeah. And IIT ends up making a conjecture, right, where it sort of translates, if you like, or tries to formulate the phenomenal properties in terms of causal properties, right? So this is really where the challenge of formalizing IIT comes in, and has been a 20-year project of really saying, how do you do this kind of formulation in the way that is most accurate to really capturing the phenomenal properties that we're talking about, right? In mathematical or in cause-effect terms, we say, right, or in causal terms. And so the culmination of this, I'm not going to get into the details of what that math looks like, right? That's the formalization, IIT 4.0 we call it now. And also on the IIT Wiki, you can learn about it in a lot of detail. But the end process of this is something that we call a cause-effect structure, or for short, we call it a phi structure. And, you can think of in a simple analogy that Giulio likes to use, if you just look at a neural substrate by itself, let's pretend my fingertips here are 5 neurons, and I can look at the states of these neurons. I can say these 2 are on and these 3 are off or whatever. And the state by itself is not particularly informative, at least not from the perspective of the neurons themselves. Okay, that sounds a bit funny,
okay,
right?
But not intrinsic.
Exactly.
Yeah.
So I might try to map on some sort of an interpretation onto those neurons, right? I might say, okay, this is a Jennifer Aniston neuron or whatever. Like there's some, I don't know, there's some neuroscience paper that found there's one neuron that turns on every time you show a picture of Jennifer Aniston or whatever. Okay. I can do something like this, right? But that's an extrinsic mapping of something, some sort of a report from someone onto what these neurons are somehow encoding or something like that. Yeah. But that's not necessarily getting at what these neurons are as a system from their intrinsic perspective. Okay, so there's a bit of an IIT jargon term. So anyway, I'm not going to get too deep into it, right? But I think you can get an intuition pump for the difference in perspective there. And so IIT says, well, if we try to figure out what this grouping of neurons in a state really is from its perspective, we have to start looking at how they causally constrain one another, right, as an integrated system, right? And so this is where the formal, postulates come in of the theory and so on. And the end effect of this, Giulio likes to use the analogy that it's like the neurons themselves are just like a map of New York City or something, right? Where, you can look at a sort of flattened version of the map and see this is here, that's there. But the city itself is when you've got the skyscrapers popping out of it, right? It's so much more than just what the map of the territory is telling you. And so if you were to really be able to see how are these neurons causally constraining one another from their intrinsic or the system's intrinsic perspective, what you end up having is this very rich physical thing, for lack of a better word, that we call a cause-effect structure, right? So it's a structure of causes and effects that is what we say this system is from its intrinsic perspective, right? Mm-hmm. So it doesn't mean we somehow discard the substrate itself, right? We don't somehow say what really exists is this abstract mathematical structure in some Platonic, universe of ideas or something like that. We don't say that. We rather say, if we want to understand this system of neurons, we have to fully unfold their causal powers, right? Yeah. From the intrinsic perspective. And when we do that, we end up with this cause-effect structure that articulates what this system is from this intrinsic perspective, okay? Now, when you then try to map properties of experience to physical properties, we then come full circle to what I was saying before of the brute identity, right? These previous identity theories or typical standard identity theories, they try to just say, well, mental states just map onto brain states, right? Neurons in a state. Yeah. We say, no, but if you just look at the flat view of New York City here, right? Yeah. It's just a brute identity. It doesn't feel like it really maps on. Yeah. But if instead you look at this three-dimensional view, right, of this cause-effect structure that kind of pops out, if you like, from this neural substrate, there you can start seeing a proper one-to-one mapping of the phenomenal properties on the one hand and the causal properties on the other, right? IIT then makes a conjecture saying there should be a one-to-one mapping with no additional ingredients. There's no fairy dust of consciousness that then comes in on top. There's rather a one-to-one mapping between every phenomenal property of experience and every causal property of the substrate of consciousness. Okay. Right? Okay. And so that's where it is what's called an identity theory, right? Where it's saying, consciousness is identical to something physical, if you like, but it isn't just forcing the identity where you say, as I like to say, it doesn't really scratch your itch of explanation. You say, you're just forcing the identity, but I don't feel how these things should somehow correlate or be identical, right? Be the same thing from different perspectives. Yeah. But when you see the cause-effect structure unfolded, then you're able to really do a mapping. And you say, that really does track with this aspect of the cause-effect structure, right? So that's where it then becomes really explanatorily powerful. Okay?
Wow. Okay.
Did it make sense?
Yeah, but the critic in me would say, okay, this is just becoming very abstract. It's very sort of the math is very complicated. We cannot yet sort of fully test this. But then in physics, if we want to account for the behavior of nature, we also end up in higher dimensions and stuff like that. Because I'm saying higher dimensions, because just to understand it, when you say sort of the map of New York, it's flat. Whereas if I would would want to visualize the structure of New York, how it is to be like all the relations between all the people living in New York, and I want the full structure of that, then you have to have sort of higher dimensions and then you end up with this. This makes me just think of the images I see in IIT papers. I see sort of the flat brain, the network, and I see then these crystals come out. And I'm visually oriented. I'm a filmmaker, so I like those images, right? So, and I can see sort of this higher dimensional structure. So, okay, then, but when we hit on metaphysics is when we would say that a certain configuration of that, sort of like, I just call it crystal, okay?
Sure,
a higher dimensional, unfolded cause-effect structure, is my exact experience of me now sitting here with you, like this quale,
quale, I think they
quale,
say.
I have to say that, the quale.
Or quail, some people say. I say quale.
And I would say there we're hitting on metaphysics here, because I'd say, no, it's just the most accurate extrinsic description of the quale I'm experiencing. That's how I would understand
you
it.
You have the intuitions of an IIT theorist.
Okay.
No. So
this is it.
Yeah. So if you like, then the question is, what are the ontological or metaphysical implications of the theory, right?
Yeah.
And by the way, there's also a middle step here, which is to say, this is only a beautiful, or whatever adjective you use, idea until you actually test the thing, right? So just to be clear, this is purely theoretical work, of course, informed based on what we know a bit about brain architecture and things like that, right? I wouldn't say it's completely uninformed from neuroscience, but the formalization of the theory is done before we really get into brains and poke things and whatever. And so all of this has to then be really empirically tested in a rigorous way. And of course, there's some initial tests that are very promising, hopeful, interesting, right? But it's this is going to be a research program for the next couple decades, probably, to really say, okay, how do you put to the test these ideas? And then after you're able to validate, right? And when I say validate, I mean in humans, probably adult humans who can report their experiences accurately, consistently, right? Because that's where we're somehow, I know I'm conscious, I assume you are, so I'm going to trust your report. But I need that validation before I make an inference to whether my dog is conscious, or a mouse, or a computer, etc. Right? So it's just to say there are metaphysical implications, which is what your question is pointing to, but I really want to emphasize the validation has to first be in place for those implications to really hold water, right? And unfortunately, IIT has come under a lot of criticism because of certain, metaphysical implications, and people have presented it as if these are IIT's metaphysical commitments or something, and they aren't. It's more like, if the theory is indeed validated, and we see, this really seems to work for the one instance of consciousness we're sure of, namely yours and mine, right? Or ours as humans, only then can we make metaphysical jumps to things, right? So it's important to have that clear. But then in the metaphysics, you then have choices of, how do you interpret this, right? You can think of it as how, where do you jump off the train here, right? And I can say what IIT's commitments are so far. I'm very much, echoing Giulio Tononi's view of this, who I also hold it, but I'm also sort of representing that view a bit, where we would try to keep this Cartesian commitment from start to finish, which I said from the beginning, right? Just say, no, everything else about the world, besides my experience, which I know immediately, directly, it's an inference from within my experience, right? So there are some people who are willing to sort of pull the rug out from experience at the end and then say, so, a typical version of this might be what's called dual aspect monism, right? Dual aspect theory. I don't want to get into too much like jargony details of things like this.
To me, that's like dualism just in different clothes, but I know philosophers.
Well, no, it's meant to be a monism, actually, right? It's meant to be a monism. So what's tricky with it? So some people will say, all right, so you're saying that experience and cause-effect power are the same thing from different perspectives, right? You're saying that, right?
Yeah.
And so this is often referred to as a monist theory, meaning there's only one thing, but it has two different sides.
Yeah.
Right. That's what the notion of dual aspect monism is. And you have different versions. You have sort of idealist monist versions, physicalist monism, etc. Now, IT resists this a little bit, because if you just think of that formulation, if you say it's dual aspect monism, you say, well, two aspects of what? You went from having two things to then sort of having three things. The third thing then has two different aspects, right? So that there's a sort of argument for that it's not the most parsimonious way to. Not that parsimony is the only aspiration here, but it. IT, at least in its form right now, doesn't really go that route. But one could easily take it this route, where you try to then say, okay, the base level of reality in an ontological sense is that you have, consciousness on the one hand and cause-effect power on the other, or let's say a certain constellation of cause-effect power, and these are one and the same thing from two perspectives, right?
Yeah.
One can take this route, and I'm sure many will do this in the future. There are a few thinkers who do this already, and I'm not too offended by it. I think one can interpret it like this. But if you really want to stay true to this, again, Cartesian commitment, where you say, all right, that itself is an inference from within my experience. So I'm never going to pull the rug out from my experience, right? So IIT takes more that approach right now. Let's say the strict version that's from Giulio Tononi's lab. That version of IIT is taking that approach to say, we do indeed posit an identity between experience and cause-effect power in a certain organization. But we describe this as an explanatory identity, which is a bit different from saying it's an ontological identity, or because that's typically seen as an ontological reduction. Meaning, okay, you establish this identity, and then you're able to say, oh, so consciousness is nothing but cause-effect power in this form.
Yeah, that's what it really is.
And we don't, exactly. So many people try to push in this direction, also critics who say, oh, IIT is just another physicalist theory.
But I must say, it does confuse me a bit.
And IIT doesn't try to take that step, though, right? It says, no, it's an explanatory identity in the sense that if I want to try to account for my experience in third-person terms, if you like, right, which is the tools of science, objective terms, this is a reasonable way to do it. And it helps me explain my first-person perspective
maybe I'm not,
in third-person terms.
Okay.
But it's never a substitute for the first-person thing. That's what I know to be real 100%.
Okay.
Right? So it stays, I mean, in its current form, it stays away from any kind of like ontological reduction, so to speak.
Yeah. But it says, when you say explanatory identity, you say this is the accurate map of this exact quale from the first person perspective. This is the exact third person perspective description of it.
Precisely.
Okay, cool.
And there are two different perspectives. And then you say, which perspective is more real? And you say, well, I know the first person perspective is 100% real. The third person one seems pretty reasonable, but that's an inference from within my first person perspective.
Yeah, because this is where Bernardo Kastrup, when I talked to him about IT, why he likes it, because he says now we have a first sort of phenomenal theory about the noumenal, what truly exists, right? We have now a theory that might bridge that gap, which then does lead to interesting, but perhaps also a bit sort of to put it like wacky implications, because IIT can sort of account then for consciousness beyond my brains. It can sort of could account for like group consciousness. What can you say that's okay? What exactly would be the implications if the theory is correct?
Well, so again, as I said, it depends on when you want to hop off the train, so to speak, right? With the implications.
I'm still on board here.
No. So there's some people, who say, well, I'm going to follow this up to where it helps us account for neuroscientific facts and so on, and it's very useful in clinical settings, etc. And there's some people who try to hop off the train a bit earlier. I'm not going to get into these implications and so on, right?
What's the end? What's the end station? I mean, I'm interested.
Exactly. Okay, the end station. I'll tell you. The end station is this: that you say, well, if I really find this identity, explanatory identity, of accounting for consciousness in terms of cause-effect power, then if I'm using my inferential power or inferential reasoning to then think about other systems out there, there's no reason why I should then say, if I see a system that also has causes and effects, but made out of silicon, but the system or whatever, some other units, but these very clearly exert cause-effect power in the same way as the system that I know, namely a brain, is exerting cause-effect power on itself, right, in this intrinsic way, then why should I say this is conscious and that isn't, right? And IT would say, being consistent with your principles, you would say, well, I would infer that. Well, let's actually, before we talk about silicon, let's talk about
bacteria
or C. elegans. Let's start, whatever, go down the animal kingdom, starting with whatever you like, cows and dogs and so on, down to C. elegans, which is a tiny little worm that has something like 300 nerve cells or sort of quasi-neurons, right? So and actually there is a cool bit of work that's being done now of people trying to formalize IIT and actually calculate phi for C. elegans. It's cool work.
Cool. That's the first living organism that we can really calculate its phi of.
Now we just have to teach it to talk so it can report to us to tell us if it's conscious or not, right? Okay, so you have, so this is again, you have to infer, and they're doing quite creative tests here. The lead scientist here, his first name is Muneki. Oh, I'm sorry, Muneki. I can't remember your surname now. He's Japanese, working at UCSF and also in Japan. And it's very cool work. Also with Alex Meyer, who's at Vanderbilt, and my colleague Matteo Grasso as well, and a few others are working on this, where they're using a very simple, so they're able to see that C. elegans likes some things and doesn't like others, right? So they're using this as a kind of proxy for saying, okay, that's maybe a really rudimentary notion of, like and dislike, right? Of some valence, of some sort of emotion, of, affect, let's say, or some sense of, I want more of that food and less of that, stimulus or whatever it is, right? And so using that, they're then able to sort of operationalize a kind of quasi. Anyway, I'm not going to get more into details here, but it's very cool work where they're trying to then, operationalize it here on a system like this. But in any case, that's future work. So you then have to think where, let's apply this theory to other systems that can't report, and it would be then, using inference to the best explanation, as it's called, right, or abductive reasoning, to say whether something's conscious. And I'm going to say yes to my dog, I'm going to say yes to my cat, and probably, also yes to the bumblebee and whatever else. Why? Well, because it has some sort of a brain of all the way down to the C. elegans. You can even identify a certain cluster of neurons that look that are kind of brain-like in the way they work. And if you don't kind of go all the way down in this inferential process, you have to say why you stop. Why do you draw the line between dogs and cats, or why do you draw the line between bees and C. elegans?
You can just calculate. You have formalized it, so you can just calculate phi.
But if you don't draw, you have to have a reason to not make the inference rather than a reason to. I think. You see what I mean? It's a different approach, and so then if you want to infer to a silicon system or something, then you have to make the choice. If I'm going to move now from biological systems to artificial systems, or to, any non-biological system, or thinking about, tables and rocks or something, I then have to make a choice. Do I think there's some extra magic fairy dust in carbon, right, in biological systems that isn't there in silicon? And if so, why should I stop? I mean, if I can't come up with some reason, why should I stop my inference process? So if I then observe cause-effect power also in some silicon system that totally mimics my brain, right? Something like a neuromorphic computer, right, is the term that's used for it. Well, then I would have a different response to this point about dissociating, intelligence from consciousness. Why? Back to our conversation an hour ago, because I'm looking under the hood of this thing and I'm saying it's wired differently.
Yeah, that's what Chris said, where the rubber meets the road.
Precisely, it's wired differently, and it has real causes and effects. It has real cause-effect power, right? Not virtual.
Do you know any, just for people to understand sort of how those compare? For instance, a bee, complex already, right? At phi-wise, sure. But just what's the hunch of IIT, that a bee versus ChatGPT 5?
Oh, I mean, the hunch would be that the bee is certainly experiencing something, and ChatGPT 5 is not experiencing anything.
Even though, like, the amount of just transistors would sort of be much higher than the neurons within the brain of a bee.
Yeah, the number of transistors doesn't matter.
Yeah,
you can
because
build a
they're
computer
not integrated, they're
precisely.
not crosstalk. Okay.
If it's just these feed forward modules, you can make it as big as you want. And if it isn't an integrated system, at least according to IIT's principles, doesn't matter.
I think a common misunderstanding nowadays is because you mentioned neuromorphic computation, and people are of course familiar with neural nets, so they already think that sort of the architecture of our AIs are quite close to the architecture of the brain. How exactly are neural networks different, not integrated, so to speak, versus the architecture in our brain?
So yes, let's say artificial systems, people will react saying, but they're highly integrated. There's all sorts of feedback loops and feedback connections and this and that and so on. How can you say that it's not an integrated system, right? And this is where you have to get a bit into the actual mathematical formalism of the theory to say, when we talk about integration, we're not just using a conceptual notion of saying, well, these look like they're hanging together pretty well, or something like that, right? I mean, integration in the mathematical part of the theory is a super precise notion, right? That's based on, you assess integration by making partitions of a system, right? It's a mathematical operation to sort of partition the system in every possible way to really figure out a detailed picture of how the system hangs together as one entity in a causal sense, right?
Yeah.
Okay, so it's really precise, making certain cuts, we call them, and whatever. You say, I have to look at every possible kind of chunked up, cut up version of the system to figure out, does it hang together, right? And not only that, but how much of it hangs together as one system, right? Because if I'm looking, so in a really simple example, I've got my 5 neurons here, right? Or 5, or they could also be some units in a computer somehow, right? Transistors or something. I not only have to really check whether all 5 of this whole little mini computer or mini brain hangs together, right? By doing these partitioning operations to see whether it really does, but I have to check actually every grouping of this. I have to check these 4 with this one left out,
every
and these 3 with those.
Is tested. Yeah.
Every possible subset has to be tested rigorously, right? And only after this process can I then figure out which of all these groupings here actually shows the highest phi value, which means it's the most integrated, right? The most integrated system. And this is really where the meat of the formalism comes in, is that it's taken many years to figure out how to do this very precisely, to figure out, to use the classic quote, we're really trying to carve nature at its joints, right? Of really figuring out, this looks like an integrated entity, this computer here. Yeah. But is it really, right? From its perspective. Okay, you have to go in and partition the system in every possible way to see whether intrinsically it hangs together. Yeah. And it doesn't just hang together for us as observers extrinsically, right? So this is a roundabout way of coming to this question about neural nets and so on, where yes, if you have a computer, there's going to be some kind of integration. Of course, there are feedback loops and all sorts of things, right?
There will be a phi. It will be just like very low.
Yes. Okay, so you can always calculate some kind of phi of that system, right? Let's be clear. Yeah. But I now have to calculate phi of sub-portions of that system. So if it has a bunch of different sub-modules, right, that somehow hang together through a bit of crosstalk and some feedback loops, I then have to also calculate phi for the sub-modules and even for the individual transistors, right? And if it turns out that a sub-module of that greater system has higher phi than the entire system, then the whole system doesn't really exist for itself in IIT's terms, right? Or it doesn't hang together.
Just one important question I do have, because if I just ask you like very low phi and you say you can always calculate phi, is there a threshold value where we say, okay, from here on is conscious and below that threshold we ignore it? I mean,
no. So again, this depends on when you want to jump off the metaphysical train of IIT here, right?
This is where it's a bit panpsychist in a sense.
Yeah, precisely. Where if it depends on how rigorous with your reasoning you want to be. Where our
I try to be rigorous. So
absolutely.
So the low phi would be like
anytime there's some phi value, there's some modicum of experience, but it's so it's not experience like it's hard to imagine what that is.
What it feels like. This cup It
No,
is
the cup.
super lo-fi.
No. This cup disintegrates most likely into what Giulio calls ontological dust. Okay. It's a nice poetic metaphor. So the cup doesn't really exist for itself. It doesn't hang together because if you looked at some sort of maybe molecular structure within that makes up this cup, probably the molecules themselves actually have a higher phi value than the cup as a whole.
Yeah.
Right.
But I getting back to I actually like that you brought that up, sort of measuring all these different subset sets and see where in what subset the cause effect structure is maximal. It's the maximum cause effect structure. Am I saying it right in IIT
or
jargon here?
Maximal cause effect power. It causally constrains itself in a maximal way, right? Okay. I like to use the really casual term. It hangs together from its perspective of causes and effects, right?
But the we cannot avoid jargon here. Yeah. But the implication I'm hinting at is that the theory, an implication of the theory is that it is able, in a formal way, to say that the consciousness that I experience in my brain, a certain subset, it would be like this neuron is still part of that consciousness, and this one is outside sort of the is not conscious. Is that?
Yeah. So things right? out. Yeah. So if you draw
it
a
is
line,
the boundary of a conscious entity. It
precisely.
can sort of draw
so
precisely the boundary of a conscious entity.
You draw the boundary, and an important piece here is that we're not saying that the outer or that things outside of the system have no influence on the system.
Okay.
Right. Sure. They absolutely do. And we refer to these, let's say if I figured out of my 5 neurons that are my fingertips, if I figured out these 4 are an integrated system, but my thumb is not part of that system, right? It doesn't have maximal phi with my thumb included. Then I would say, okay, my thumb is a background condition for the system, right? In a really simple sense, you could say some retinal neuron probably doesn't form part of the main complex of my brain. Sorry, IIT jargon term. It doesn't, my retinal neuron isn't part of my experience. It's not part of the substrate of my consciousness, right? Yeah. But it's a very important background condition for it. Yep. And it does have it has causal power or influence on the system. So you have to also take that into account, but that doesn't mean it's part of what the system is from its intrinsic perspective.
Yeah.
Right. And this is actually precisely formalized in the math of IIT.
Yeah. And
it's very precisely formalized.
How does it sort of relate to, I see now in consciousness studies, we interviewed Robert Lawrence Kuhn, you know him?
Sure.
He made this map of all the studies.
Yeah.
One of the categories I find interesting and that somehow falls under materialism, and I don't know, okay, and let's not go into the metaphysics of it, but an activist theories of consciousness or that are very much into embodiment and say, okay, we have focused way too much on the brain. Consciousness is about sort of being in this world, so it is embodied. And from that perspective, I say that the boundary of my consciousness clearly is the boundary of my whole body, and everything contributes to consciousness. I also see this culturally, it's sort of without people like really understanding it in a scientific term, say that trauma is stored in my body. And there are, of course, studies that do show that sort of the body knows, right? That stuff like that. How does IIT relate to that? It does seem pretty much brain-focused to me.
Yeah, okay. Very good question. I'm going to try to be concise with responding to it. So first thing is to be very clear about what is it that we're really talking about with consciousness. Right? Yeah. So consciousness is my experience. Okay, so certainly I experience my body as, being part of me, right? And even if, I don't know, we have parts of our, clothing or something that we somehow even identify with as part of me or whatever, right? I'm also very sympathetic to embodied cognition, frameworks for things. Actually, my whole field of linguistics that I'm in is very, very much part of this
We
this
talked
world.
about cars briefly, right?
Also. Also. No, okay, that's a side conversation.
Yeah.
No,
for
so
some
I'm very
people,
sympathetic
sports car is part of their,
Yeah,
I'm kidding.
it could be. Yeah, it's part of their extended self or something.
Yeah, okay.
But we have to be precise that we're talking about consciousness here. And so in a really simple example, have you ever heard of phantom limb syndrome?
Yeah.
Right?
Yeah, that's that you still sense it, right?
Yeah, precisely. If you cut off
yeah.
precisely, you cut off someone's arm and they still think that they feel somehow that they have an arm, and often it's painful. I mean, imagine they're still having pain, in their hand or something that doesn't even exist.
Yeah, that's weird.
Okay, so there's something, clearly about the body that somehow feeds into what ends up being the content of my experience. But my experience itself is not dependent on, on cells in my hand. That's the point.
Yeah.
Right. The substrate of that experience is something going on in the actual brain.
Yeah.
Right. I think a very crude example that maybe gets the point across. To say, experience is, you could, in theory, let's say, okay, let's do a thought experiment here. Take your brain, suddenly, put it on ice, put it in a vat with all your memories, all of the things that you, through your embodied experience of the world, have stored, for lack of a better word, in your brain. Freeze it, put it in a vat, and then reproduce the same, exact same activity patterns, right? Somehow do that, right? Then the question for you is, are you still experiencing something? What do you think?
If my brain functions, that's all intact. I'm just disembodied. In this case, I'd say
and you have all the same imprints from your mind, but it's just you just aren't connected to a body anymore. I'd say that the
contents of my experience will be like severely different, but there perhaps might be some level of awareness, or
Okay, all right. So now we can do the same thought experiment, but but it's just, you don't have to cut your head off and put your brain in a vat. But you just imagine being in dreamless sleep, where you're basically functionally disconnected from the environment, right? Sorry, dreaming sleep, right? In like rich dreaming sleep, right? Imagine the most vivid dream you can think of.
And then it's
and
rich.
Of course, for all the neuroscientists out there, of course, it's, there's evidence that we're usually somehow minimally connected to the environment still. Okay, but let's posit a condition where our sensory input is really null, which is, I think, something to at least posit in a theoretical construct. You can still have an immensely vivid experience. Right, just dreaming. That is the brain in the vat experiment right there that we do basically every night when we go to sleep.
Is it because wouldn't there be sort of like biochemical processes in my body that feed into my brains that are not my senses at that time? My heart is beating, there's blood, so that we don't know all those effects, right?
But if you're able so let's now put your brain in a vat again properly.
I don't
like
it.
Okay, and if you're able to actually in what the brain is doing, right, mimic the exact. So you don't actually have let's say the input array, right, directly from the heart or something anymore, but you're able to mimic that input array in the brain in a vat or something, right? Let's say that's the sort of scenario. Yeah. Right? I mean, IT would say you're still experiencing something there.
Yeah. That to me seems plausible.
Okay. Yeah. I mean, the phantom limb, going back to the phantom limb one is probably all you need to really get the point that, my experience of my arm is actually not dependent on my having an arm. And that's amazing, right?
And the other way around is that what's that one with the rubber hand?
Illusion and so on. Yeah, absolutely. Yeah. And so the reason why this is important as a sort of thought experiment is to think the insights from theories like inactivism, embodied cognition, and so on. IIT wouldn't throw these out the window at all, right? They would say, actually, these are very valuable for helping make sense of why we as human beings experience things the way we do, right? Because what we have in our intrinsic causal structure, that is our, let's say, consciousness from this third person perspective, in IIT's framework, we've gone through a process of evolution and of development from childhood till now, and of learning, right, that we're doing right now, that is actually a process of taking, let's say, causal processes from the environment and internalizing them in the intrinsic causal structure of our mind. And when I say external, I mean my hand is also external in this case. Yeah. Right? You see that? Yeah. And so the way that we are conscious, the way we experience things as humans is certainly somehow, what's the right word for it? Conditioned by, or somehow, the inactivist story or the embodied story tells us something about why it is that we as humans feel things the way we do. And it would also tell something about why a bat feels something the way it does because of its embodied experience. But that is very different from offering an account of experience right here and right now. Yeah. You get what I mean? Yeah. Because the inactivist story and the embodied cognition story, it's more of like a diachronic story, right? It's something that is about, something that unfolds over time, right? This is IIT's, my version, my way of describing it, right? I think it resonates with IIT. But IIT is saying consciousness is something that is not diachronic. It's right now. If you want to be as strict as possible with Descartes' insight, the only thing I know is that I'm experiencing something, and I only know that I'm experiencing it right now.
Yeah.
Right? Experience is actual, right? And so in IIT's framework, because experience is actual, we have to also look in a physical sense to something that is actual, not something that is unfolded as a process over time or something. However, the thing that is actual in the physical sense can have been conditioned, and it has been conditioned by all of the past, causal interactions we've had with the environment. Yeah. Does that make sense?
Yeah.
So it accommodates it. It's more like, as I see it, you first have to have a theory of consciousness and a theory of being, right? And then, that's the same thing in IIT's framework, right? And then when you start thinking about, well, what is it like to be the system? Then stories from inactivism and embodied cognition, they can help inform very much about, like, why is it that being a human feels like this versus like being a bat or something?
The end station is, of course, the implications, for me at least, in thinking of sort of larger configurations of consciousness, say like a group mind, a hive mind, or a universal mind. We had at the workshop, and I interviewed Christopher Koch about his own mystical experiences on psychedelics that left him like truly puzzled. Also from an IIT perspective, when I interviewed him, he found it hard to make sense of that. What is your take on that? So, like, first, like the sort of the materialist way to look at it would be a question I have is, of course, if we just like can link ourselves up with neural links, etc., what would happen then? Would that become sort of a collective phi that at some moment becomes like more than the maximum phi in my head and your head, and then we, as Christoph said, we have a new Hans Jeremiah mind, and those profound experiences of oneness that can be accompanied with out-of-body experiences and stuff like that. What are your thoughts here?
Sure. So one in the formalism of the theory, it's called the exclusion axiom and postulate, right? But I'm going to try to say it in regular terms, right? But anyone can look this up if they like. But it's simply to say, a feature of consciousness is that my consciousness is somehow, definite, right? It has some sort of a there's some sort of a boundary between what I'm experiencing right now and what you're experiencing. And my experience, literally what I'm feeling, is not part of your experience right now, right? But per IIT, if you were really following the theory precisely and had the right technology to do this, we could start connecting our brains, thread by thread, synapse by synapse, and at some moment we would no longer. So at the moment, the phi of my brain is maximal, and the phi of yours is maximal. But then at some moment, if we start connecting, there would literally be one connection after which, if you did this measurement of phi, you would find our two brains together have a higher maximal of phi. And so the theory would predict that, and here I would actually ask it more as a question, what does that feel like? Does that mean that you and I are obliterated as ourselves, or does it mean that we become actually a Hans Jeremiah, group mind, actually? I would be more inclined to say the latter, where I would say I don't feel as if I'm obliterated as a person, but somehow it certainly changes the conscious experience pretty dramatically, right? Yeah. Where suddenly, you can't even think I have access to your memories and you to mine or something, but it somehow fuses in a sense, right? It somehow fuses into a single one.
The Borg in Star Trek. And what about sort of these experiences of
mystical experiences?
Mystical type experience where the phenomenal report will be, I was the universe.
Yeah. I'm also very interested in meditation and these things from the inside out. And so I don't like putting too strict borders on what I think are possible. Yeah. But we could put a sort of hypothetical out there, right? If you, let's say that you reported, or let me do it my way. So let me say I report a deeply mystical experience in which I feel that I'm completely one with you.
Yeah.
Right. And so that's my report. That's the way I describe it. I'm one with the universe and one with you. Right.
Yeah.
And you're sitting here, right, looking at me, and I'm reporting this to you. Are you one with me? Right, from your perspective.
Yeah, that's a good one. Yeah.
I mean, have you fused with me as well?
Yeah,
right?
If
or
I'm not
something.
on any substances as of right now, I'd say I'm still pretty much me. And
there's still some sort of a boundary.
Sort of your experience of oneness. I appreciate it and I respect it. But
yeah. So in any case, I mean, I'm happy to stay a bit agnostic about the limits of possibility. I'll put it that way.
Yeah.
But according to IIT's formalism, probably the account of an experience like that would still be that the feeling of oneness with the universe, it's an immensely rich feeling, right? I mean, it's something to aspire for, absolutely.
Yeah.
But it doesn't necessarily mean that literally your consciousness has fused with my consciousness into a higher consciousness or something like that, right? Yeah. There's still, you could say, as a sort of border between your experiencing something and my experiencing something. So I think there might be a kind of semantic difficulty there when someone says, I have the feeling of being one with everything. I mean, that's a very beautiful experience, and it's even a good description of it. But if you're saying, does the rest of the world also suddenly cease to exist as individual consciousnesses, right, and suddenly turn into a hive mind in that moment of you having the mystical experience? Well, probably not really, right?
Yeah.
So,
IT, of course, is a great theory of sort of describing consciousness from an extrinsic perspective, and that I think will be its great value if we can map sort of the intrinsic reports of phenomenal experiences with the extrinsic description of this theory. And I'm curious about sort of your own intrinsic experience. We briefly had a pre-discussion where you told you're a meditator, and how sort of in thinking about IIT and sort of states you experience on meditation, has it sort of, how do those two go hand in hand, or is that still a divide for you? Has it informed you? So,
so I can say from a meditation perspective, meditation practices, especially if you're in a more formal tradition like a Buddhist tradition or something, there's no the proof's in the pudding of the practice itself, so to speak. So, I mean, if you're really committed to a meditation practice, you actually get the benefits and even the validation, right, of the truths that you're cultivating through a meditation practice, actually through the practice itself, right? So it's an important thing to say that I don't think like learning IIT is going to like teach a person to be a better meditator or something like this, right? No, and I'm not that you were implying that, right? But it's just to say, so it doesn't. Meditation has its own. The proof is an intrinsic proof, right? That really it reveals itself the more that you actually practice it. So, but what's very interesting, so from my perspective, relating the scientific approach of IIT with phenomenological questions, right, of meditation and states of consciousness and so on. On the one hand, there can be a very interesting wedding of or complementarity, where actually meditators and the states of mind that meditators can offer can give a very interesting group of subjects that you don't find in normal society, right? To study certain aspects of consciousness.
Yeah.
And that's very useful for IIT, for sure. So the community of meditators can offer, if they like, their minds in a very meaningful way for science. And IIT has very interesting, studies to do that we've already actually started doing, right? So on the one hand, that aspect I think is very beautiful. I can mention a bit more about this if you like.
I'm curious because that's like a real fun question that just pops to mind. If meditating makes us more hi-fi in a sense, do you understand? Does it influence your FI, your integrated information? In because that to me is also interesting about the theory. People report when we do measurements, brain activity goes down, experience goes up.
Sure. So I don't think, I honestly wouldn't fixate on phi as a number here because it can be clinically, I think, very useful to come up with proxy measures of something like phi or approximations of it for a clinical setting, to be able to say, is this vegetative, state patient, conscious or not, etc. Or non-responsive patient, are they conscious or not, or in a vegetative state? So that kind of thing can be incredibly useful. But if we fixate on it too much of thinking about like levels of consciousness and so on, I think it's difficult. I'll just leave it at that, right? It's very, very difficult. It's like saying, is the experience of, downhill skiing at 100 kilometers an hour, is that more phi than the experience of, playing a really nice piece of music on the guitar? Yeah. It's like, they're qualitatively totally different. I can't say what's more or less. I don't know. So I think it's a very difficult question, right? So I wouldn't really frame it in terms of high phi, low phi, or whatever, right? It is worth mentioning one way that the meditation world or the brain states of meditators has been very useful actually for IIT already. It's worth mentioning one way that's not really so much about level of phi and so on. If I may, is that okay to also mention this research? Yeah. Where, in IIT's framework, as I've said a few times, consciousness is not so much, or it's not at all about doing something, but it's about being, right? And a radical implication of this is that if you have, I think I said it before, if you have an actual brain state that is mostly quiet, with neurons mostly inactive but not inactivated, most other theories, if not all, I don't want to be too broad, but most other theories would say that's not experiencing anything. Why? Because the brain's not doing anything, right? Quite simply. But IT would say, no, we would predict that it is indeed experiencing something, and it's an incredibly rich experience, right? And one that IT would say is probably expansive like space. Okay, now the problem is we need to find people who can produce a brain signature that looks like that. Well, actually, long-term meditators can do that, right? And that's very cool. And so we've actually done studies of trying to test this sort of silent cortex hypothesis by having long-term meditators first go into retreat settings, maybe 5 or 7 days of just meditating all day, really practicing to be able to deliver good results, training on doing mouse clicks at the right time and so on, to be able to report experiences that they describe as pure presence, right? Which you can sort of roughly think of as being awareness without having, you could say resting in awareness, but without having an object of your awareness, right? If that makes sense to listeners. And indeed, we have meditators actually subjectively report, yes, I'm having an experience like that. And then we look with this high density EEG recording, what's going on in the brain in that time. And there's preliminary evidence that more or less there's widespread deactivation of neurons, right? Of course, this is incredibly coarse. If people know how EEG techniques are, you're actually measuring the behavior of groups of millions of neurons at a time. But if you're able to see a widespread deactivation, that makes you start thinking, right? That there must be something in that. And you really see this in the charts that are in we have one paper on this so far, where you really see a radical drop off of activity. I think it's especially in the gamma band. I can't speak too eloquently on why that's especially relevant. I think in delta as well. But it's pretty, it makes you think a little bit. Certainly if you're working within a functionalist paradigm. So those kinds of results are super interesting for IIT, right? And I think other frameworks would say, well, we don't really know what to do with that.
Yeah, it's just wonderful that it can account for that. It seems to be able to account for that. We'll put all the links, if you can share them with me. I'll put it down there to end with like
and it's important that we just say about that, where some people might be thinking, but why should that within IIT's framework somehow correlate to or with a conscious experience? And it's quite simply that even though the neurons are mostly inactive, right? Not inactivated, but mostly inactive, that doesn't mean that they're not still causally constraining one another as a system, right? So just being in an off state is something that is a label we give extrinsically from the outside. But from the intrinsic perspective of the system, there's no such thing as being off or on, right? What there is causal constraints of the system on itself. So this all off state is still causally constraining itself as a system. We don't notice it extrinsically, but IIT would say from its perspective, it is indeed still, hanging together as one intrinsic cause-effect.
Jeremiah, I want to close with a final question. Before that, I want to thank you for the best explanation of IIT. Really, thank you so much. I've learned a lot during this conversation, and it will probably raise new questions, but I've learned a lot, and I think people watching with me. So thanks for that already.
Oh, my pleasure.
And I'd like to end with sort of like on a meaning level, on a personal level, what this means for us. I personally, and I'll give you my take, I love when you say that it's about being and not doing, because so many theories of consciousness in the end are about doing. And if we look at where AI is going, it's very much about output, reasoning, and doing, and not being. And I find it very important that science can sort of help us be clear about the difference between the two, the difference between intelligence and different consciousness. And I think it's a very rich theory in that sense, and that to me is meaningful. So that's why I like IIT, and I love talking to you about it. And how's that for you?
Yeah. Well, actually, I would love to tie this final question in with your previous one.
Yeah.
There was also a more personal question about, relating it to also maybe introspective practices or meditation practices and so on. And one thing that really drew me to IIT was the implication that it has for freedom, right? For real free will. And this to me is, I think, really important when you look at the overall tendency in our society. You could kind of call it like a scientistic tendency to think, okay, consciousness is just sort of coming along for the ride. What's really real is the neurons firing, and consciousness is an illusion that's sort of whatever. There are all these different theories that come out that often then say, okay, but we need some compatibilist way of still thinking that we're free, but we aren't really, and so on. And a super important outcome of IIT is actually really articulating a rigorous notion of free will that really makes sense. And so tying this together with practices like meditation practices, what is the point of something like a rigorous meditation practice? Well, it's that actually choose your future in a sense, right? It's to become a better person, to become a better human being. And if there isn't free will, what the heck are we doing with that? Honestly. Yeah. I mean, I'm not satisfied with a compatibilist view of saying, I think I'm freely, improving myself, becoming a better human through practices such as that and so on. And so that for me is a really beautiful piece of this theory, that it attempts to offer a rigorous scientific case for certain insights that we have from spiritual practices going back thousands of years. I'm a bit partial to the Buddhist one, I'll say, but it doesn't mean that there aren't wonderful insights from others as well. And I think that's really important, right? That it's done in a way that's not trying to, that respects the differences between a spiritual practice and a scientific pursuit, right? It respects these differences very clearly, but it also then says there is a way scientifically to reinstate the primacy of human experience in the scientific endeavor. I mean, which hopefully listeners get a sense of how IIT does that, right? With its starting point and so on. But it's not just from its starting point, it's also then from the implications that follow from the theory, right? And one of those is that we indeed are the authors of our future in a real way, right? That in the longer future, that it really is something that we're creating for ourselves right now. And that's important. I mean, that's a super core insight of also just humanist traditions, wisdom traditions, right? And so practices of self-betterment and so on, I mean, all of them, I think, rely on having a rigorous scientific formulation of something like free will. So
thank you so much for the conversation, and thank you for watching. And we'll put all links below, and also a link to your wiki so people can look up and dive deep in. And I hope, Jeremiah, if a lot of questions come in, we can have another sit down to dive deeper. But this has been sort of a wonderful ride.
Yeah.
Thank you so much.
Thank you so much for having me.
No, thanks. The pleasure is mine.